Okay, ladies and gentlemen, what we're going to do here is I'm going to go through these problems and kind of pinpoint what you need to know for the test tomorrow. All right, first of all, let's take a look at this. The instructions on this is just basically graph the inequality. All right, now you don't have to do anything in particular. You don't have to solve it. Basically, you notice that there's a variable on each side. So really what I'm looking for is the fact that you understand that if it's this or this, it's open. But if it's less than or equal to or greater than or equal to, it's solid. Okay? And the fact that you know which direction the graph is supposed to go. So let's take this out of the way. And let me show you this right here. So the equation is y is greater than -1. Notice on the graph, we plot -1. So you don't have to put all those numbers. Simply just do this. Show me -1. Show me that it's open. And since it's y is greater than, show me to the right. And that's really all I'm looking for. Now, on the next slide, this one says write the inequality shown. Now, I'm giving you the graph. So what I want you to do is give me the equation that goes with it. For instance, and you can use any variable you want. You can use x, y, z, n, it doesn't matter. Notice this starts at 2, all right? Notice that the arrow is going less than. So I know the number is going to be less than. So you know what? Let's just put n. n is less than 2, and it's open. Here, you notice that this one is solid. Okay, well you know that the numbers are going to the right, so if you have some number, it's going to be greater than or equal to -3.5. And in your packet, this kind of goes through that information. Okay, let's go to the next one. On this one, I'm asking you to define a variable and then write an inequality for each situation. So for instance, the temperature must be at least 72 degrees Fahrenheit. So I'd use T for temperature. No more than 12 students were present. So I'd say S for students. All right? And no more than, that means it can't be more than 12. It has to be less than or equal to. And then it takes less than 30 minutes to complete the lab activity. Since I'm talking about a lab activity, I'd probably use L. Well, let's take a look at this example down here. Okay, let's blow it up. Now, on this particular problem, it says write an inequality. It's the same information. Applicants for a driver's permit must be at least 16. That means if you're 15, 14, 13, 12, or younger than 16, you can't get a permit. So your age must be greater than or equal to 16. And then, of course, that means solid, and then greater than to the right. So A for age. Now, let's go to the next section. This next section, now let's take a look at this, okay? First of all, the instructions say solve each inequality and graph the solution. Well, in this particular case, these are one-step equations. First of all, you have an adding 3, you have an adding 4, subtracting 3, subtracting 1/4, subtracting 7, adding, subtracting, and then a +7. So all those things require one step to get the variable by itself. And then, of course, you have two word problems down here. So let's take a look at the word problems. Tammy wants to run at least 10 miles. That means she wants to really run more per week, but the minimum she wants to run is 10. And it says so far this week she's run 4.5. So 4.5 miles plus whatever else she's going to run is going to have to be more than 10 or equal to 10. So it asks you to write and solve an inequality to determine how many more miles Tammy must run to reach her goal. So we'll cover this problem here in a second. Let me back this up just a little bit. All right, so now let's take a look at these examples. Now these examples right here, it's basically the same thing. Notice the opposite was to subtract 6 on both sides. And like I've told you, this is like a river. You go to the other side of the inequality sign. And 2 minus 6 is a -4. So what you end up having is x is greater than -4. It's open, so notice it's open, and it's greater than, so it goes to the right. You don't have to put all these other numbers. Just put the line with the -4 open and to the right. Now, in this particular case, it was a -1.3, so we added 1.3 to both sides. Kept the inequality sign the same, so n is less than 4.5. So here's 4.5, less than is to the left. All right, so now let's take a look at this word problem, okay? Now this word problem, we said that she wants to run at least 10 miles. So whatever she wants to run has to be more than or equal to the 10 miles? Well, this breaks down into she ran 4.5 miles already, plus whatever else she wants to run during the week is going to be more than or equal to 10 miles. So we're going to subtract the 4.5 from both sides. And then R is going to be greater than or equal to 10 minus 4.5 is 5.5. So she still has 5.5 miles to run or more. Now, if I were to put a number line, all right, we're going to do 5.5 right here. It's solid because she can equal that, or she can run more. She doesn't want to run less. Now, let's go to the next problem. Now, notice I'm going through these problems quite fast. I really want you to slow the video down, take a look at each problem, and try some for yourself. All right, so on this particular problem, it says solve each inequality and graph the solutions. Well, if you notice, all of these either deal with multiplication or division. Like this is 3a is greater than, is less than or equal to 15. So you would divide by 3, and you'd get a is less than or equal to 5. And then, of course, you would graph it. Now, that's for all of these problems on this page, okay? Now, let's take a look at what they did. Oh, by the way, let's take a look at this one here. This is 2 divided by 5 times x is less than or equal to negative 10. Remember, you have an option. You can either multiply both sides by the reciprocal. And remember, when you multiply by a reciprocal, this cancels out, leaving you with x. Less than or equal to. Now, you can multiply this straight across and make this negative 20 over 5, which reduces down to negative 4. Or you can cross reduce. 5 goes into 10 2 times, and negative 2 times 2 is negative 4. So you get the same answer no matter which method you choose. All right, now I'm going to back this up. Let me undo some of those things. All right. Now, let's look at the example that they gave us. All right. I'm going to move this out of the way. And let's take a look at these examples. Let me move it a little more. Let's take a look at this one. Okay. Now, on this particular problem, notice it's p divided by negative 3. And it says, since p is divided by negative 3, you're going to multiply both sides by negative 3, which is what they did. So when you do negative 3 times 6, that gives you negative 18. Now remember, you multiplied both sides by a negative. So it says change the signs. So now we went from less than or equal to now greater than or equal to. And so it's solid and then to the right. All right, slide number 6. Okay, now on this particular problem, these are just nothing but word problems. Now, notebooks cost $1.39. All right, what are the possible numbers of notebooks that can be purchased with $10? Well, you know you can't go over $10, so it's going to have to be less than or equal to the $10. Now, if it's $1.39 per notebook, we're going to let n equal notebooks. Okay? Now, if that's the case, then I know it's going to be $1.39 for every notebook. So $1.39 times n. That tells me I'm going to do a division here. So $1.39 and n. So whenever you do this, n is less than or equal to. Now you got to figure out how many times will 10 or what $1.39 go into 10. And I believe I didn't do this one yet, but if you let's see if I can pull up a calculator here. No, not working. All right, so no. If you notice, what's going to happen is I think it rounds up. I think I did this in class during 7th period, but let's say it goes to 6 point, that's probably not right, but let's say it goes down to 6.217. I'm making this number up. Well, you know you can't have 0.217 of a notebook. So basically, round that up to 7. All right. Actually, sorry, not round it up, but round it down to 6, and you can get 6 notebooks because you can't buy 0.217 of a notebook. So again, off the top of my head, I'm not really sure what that divided out to. You can do it on your calculator. So whatever this is, round it down. And I think it turned out to be like 7 notebooks I can buy. Okay, if you want another example of that, you can actually look at this one, and this one did the same thing. Notice that it's 30 over 5.5. They didn't divide it all the way, so but it did say only whole number pizzas can be purchased. So you can't buy 5/11ths of a pizza. I think someone would be really mad if you did that. If you received like half a pizza, or not even half a pizza, just 5 pizzas and some slices. So basically, round that down to 5. So you can purchase less than or equal to 5. That's why it said you can buy 0, 1, 2, 3, 4, or 5 pizzas, just not 6, with that $30. All right, let's go to the number 7. On number 7, oops, I didn't mean to do that. On number 7, it's saying solve each inequality and graph the solutions. Now, on these particular problems, these are all multi-step, okay? For instance, if you look at this one, you're going to have to subtract the 4, then divide by the 3. Here, you're going to have to add the 5, then divide by the 2. On this particular problem, if you have m plus 3 divided by 2 is greater than negative 4, you want to get rid of this 2 here. So you're going to multiply both sides by 2. You get m plus 3 is greater than negative 8. You're then going to subtract the 3. Now, if you want to follow and just continue circling the variable as you go along, you get m is greater than negative 11. Draw me a little number line, put a negative 11 right there, open circle, and to the right. And that means anything greater than 11. Now, let's take a look at some of these other problems. Let me make this bigger here. Let's take a look at some of these other problems that require a little bit more work. Let's take, for instance, number 45. Okay, number 45 is a good problem. Number 45 has some fractions in it. Well, my common denominator is going to be 10. So if I have 1/5 x plus 1/2 is greater than 4/5. If I multiply everything by 10, multiply by 10, multiply by 10, what you end up getting is 10 over 5 x plus 10 over 2 is greater than 40 over 5. Now you can go through and reduce all these. This reduces to 2x. This reduces to 5. This reduces to 8. Now you have a two-step equation where you subtract 5 from both sides, and you get 2x is greater than 3, and then divide by 2. So x is greater than 3/2. And then, of course, you would graph it. So put 3/2 there, put a circle, and it's greater than. All right, number 8, or slide number 8. On this particular problem, Carl's Cable Company charges $55 for monthly service plus $4. So it's a flat fee of $55 for monthly service, or $55 per month, plus $4 for every pay-per-view movie. Now the telephone cable company charges $110 per month with no fee for movies. But look what it says. For what number of movies is the cost of Carl's Cable Company less than the cost of the Teleview? So we want Carl to be less than the cost of the Teleview. Well, it's $55 per month. So here's Carl, $55 per month plus $4 per movie. All right, and we want it to be less than the Teleview, which is just $110 per month. So basically, you've already set up your problem. You've already got it in a manner in which you want to solve for Carl being less than Teleview. We're going to subtract 55 from both sides. 4m is less than 110 minus 55 is 55. Then you're going to divide by 4. All right, and then let me move this up a little bit. And you're going to get m is less than 55 divided by 4. Now, you know that 4 will go into that 13 times, I believe. So if for some of you who don't have calculators, you know, you can do it the old-fashioned way and just keep going. So you got 3, and then so 13 and 3/4. So m is less than 13 and 3/4, which is 0.75. So 13.75. Now it wants to know for what number of movies is the cost of Carl's Cable Company less? Well, we just solved for m, so that means less than 13.75 movies. Well, we know, like from the previous problem, we can't have 3/4 of a movie, so it's going to have to be m is less than 13 movies. So that means 0 through 12. Any of those would give you an answer to the solution. Now, Let's look at this one. Now, I didn't spend a lot of time on that word problem. You're going to have to stop it and go back over it and replay it, I guess. On this slide, solve each inequality and graph the solution. On these, notice that there's variables on both sides. Variables on both sides. So you're going to have to move one to the other. In 53, you have to distribute. Now, be careful on this one. When you multiply a negative by a negative, I'm going to do this one over here. So negative 3 times 2 is negative 6. But negative 3 times q is a positive 3q. And then greater than or equal to 6 times q is 6q. And then 6 times 1 is 6. And then you're going to solve it for q, so minus 3q on both sides. And bring down the negative 6, bring down your inequality. 6 minus 3 is 3q. The q doesn't go away. Bring down your plus 6. Now, I'm going to subtract 6 from both sides. I get minus 12 is greater than or equal to 3q. Divide by 3, and you're going to get q is less than or equal to negative 4. So on a number line, let's put that negative 4. Now, if this confuses you, flip it around. Q, remember, here's your negative 4, but it's pointing towards the q, so flip it around. Now you can read it. Q is less than or equal to negative 4, so we want solid and to the left. And now finally, oh, wait a minute, let me go back to this other one. If you look at 57 through 61, let me take this and move this over. Look at these down here. All of these problems have a parenthesis. Please make sure you distribute. Okay? Please make sure you distribute. Now, let's go to that next page again. All right, on this one, I'm not going to solve any of these. I'm going to go by what they've already done. These are compound. Notice this one's in the middle, and this one is an or statement. So in solving both of them, look what they did right here. All right, let me blow that up a little bit. Okay? From the center, they solved it from the center here. They subtracted 5 from all 3 sections, and they left that c there. All right? Now, when they did that, they were able to get c is greater than or equal to negative 8. That's this one. And then also c is less than or equal to 6. Now, I told you that you're going to look at that as one solution, and you're going to come down here, you're going to put your negative 8. You're going to come down here, you're going to put your 6. And it's an and statement, basically. It's a compound statement, so you're going to connect them in the middle. Now, look at this or statement. It's this or this. So negative 2 plus 2. So notice they added the 2 to both sides. 2 plus 2 is 4. Subtract the 3. 1 minus 3 is negative 2. So it's t is greater than positive 4. Now notice, just because this one is on the left, all right, you have to look at these answers and decide which one's smaller. So notice, 4 is bigger than negative 2. Therefore, on a number line, they put the 4 here, all right? They put the 4 here, and then they put the negative 2 right here. The negative 2 happens to be open, and the number is less than. The 4 happens to be solid, so solid and greater than. And there's your or statement. Be careful how these are read. All right, that is it, and good luck tomorrow.